Alright, next we inspect another mixture problem. This one's a little bit different. We have the Jackson Coffee Company charges $17 per pound for Mexican blend coffee and $15 per pound for Peruvian blend. How much of each type should be used to make a 28-pound blend that sells for $16? Okay, step 1 says we read very carefully and start picking out information. So we have $17 per pound is the price for Mexican blend. We have that $15 per pound is the price for Peruvian blend. We want 28 pounds total of a blend that sells for $16 per pound. Alright, we take stock of what we have. We have that the price of Mexican blend is $17 per pound. The price of Peruvian is $15 per pound. We want a total of 28 pounds, and this blend sells for $16 per pound. So these two things are linked, and those two things are how we're going to make our blend. We were asked to find how many pounds of Mexican blend we should use. I will very creatively call that M, and also how many pounds of the Peruvian. I will very creatively call that P. So we're not dealing with concentrations this time, but the setup is still very similar. We start by recognizing that we want a total of 28 pounds of blended coffee, and that is going to come from however much Mexican I mix with Peruvian. So the easy equation is out of the way, or well, relatively easy, comparatively easy. The second one, okay, we're going to go back to our unit analysis. We had $16 per pound, and we're making 28 pounds of that. So this is similar in style to the concentration question. Right, those pounds will cancel, I'll be left with dollars. What I did on the one side, I'm going to mimic on the other side. I'm going to say I have $17, that's dollars per pound, of the Mexican blend, and that is in pounds. Similarly, $15 per pound of the Peruvian blend, and that's in pounds. Looks kind of ugly, so let's clean it up. That is 16 times 28. Our left-hand side is $448. Oh my goodness, that is expensive coffee. Okay, and that is going to be 17 times M plus 15 times P. I'll just rewrite this. Should be an equals there. Okay. Once we have our equations, can move on to step 3. We can solve this either using substitution or elimination. These lend themselves very well to substitution because in equation 1, again, we have just 1's out in front. That makes this quite quick to solve. I just subtract one of the quantities from both sides. This time I'll subtract p, solving for m. Then our algorithm says, chunk that in here. So 17 times m, but we have m is 28 minus p. We should take 17 times 28, which gives us 476 minus 17p plus 15p. I can see we're going to have negatives again, but that's okay, we can handle it. $476. Excuse me, that is a negative. Negative 17 plus 15, negative 2p. This is a 6. I can subtract 476 from both sides. 448 minus 476, and negative 28. And that is equal to negative 2p. Final step, divide by a negative 2. That gives me 14 is p. So 14 pounds of the Peruvian blend is what I should use. Next step in our algorithm says to back substitute this into one of the original equations. I'm going to go for that one. Tells me that m is 28 minus p. M is going to be 28 minus 14, which is also 14. Okay. Step 4 says we better check this. I would be especially suspicious of the fact that they came out to be the same thing. Okay, we know 28 is m plus p. We just used that. 14 plus 14 is indeed 28. So check the second one. So it said it was 448. 17 times m plus 15 times p is 448 equal to 17 times 14 plus 15 times 14. Seventeen times 14 is 238. 15 times 14 is 210. And yes, this is 448. So even though we were suspicious, turns out it was okay. We answer the question now. We should blend. £14, LB for pounds, of the Mexican coffee. And £14 of the Peruvian.